Well, hello there, folks. I hope you're doing well. In this video, we will be talking about Chapter 4.1, which involves finding the increasing and decreasing functions. To start off, we need to, first of all, define what increasing means and what decreasing means. So, in general, a function is considered to be increasing when the y values go up as the x values go up. And it's considered to be decreasing when the y values go down as the x values go up. I mean, this kind of makes sense. So if I have a graph here, this is similar to the one that you might find in the textbook. With that graph there, we have it. The y values are decreasing as the x values increase. So this is a decreasing graph at that point. Then it starts to increase, then it starts to decrease, etc. So increasing when it's going downward like that. So decreasing when it goes downward, increasing when it goes upward. And there's a way that we can actually test for this. And so the test is also found on that page, on the next page. If you're following along in the textbook, we started on page 167. We're now on page 168. So the test for increasing or decreasing functions is this. If the derivative of a function f at x is greater than 0 for all x in an interval I, then f is increasing on I. And similarly, if f prime x is less than 0 for, I got too excited there, for all x in an interval y, interval I, then f is decreasing on I. This, hopefully this makes sense, but if it doesn't, hopefully through the examples, it will make sense. So let's just start with example number 1. Find the intervals in which the function f of x is equal to 1 minus 5x plus 4x squared is increasing and decreasing. So example 1, we have f of x is equal to 1 minus 5x plus 4x squared. So f prime x, because we need to find out the derivative to use our rules here, f prime x is equal to, the derivative of 1 is 0, the derivative of negative 5x is negative 5, and the derivative of 4x squared is 8x. So let's take a look at these two graphs, just to make it maybe a little easier. Bring up my graphing calculator there. Make it a little bigger for you folks. So I will first of all put in 1 minus 5x plus 4x squared. I'm not sure what's going on there. I did it wrong. Sorry. 1 minus 5x plus 4x squared. Take a look at our graph there. We see it is just a normal squared function, quadratic function, which we would expect. And if we look, we can see it's going down, tending downward to this point here, and then it goes upward. So it's decreasing to this point, increasing to this point. I mean, we can use our graphing calculator to find what that point is, but we're going to use the math instead. We're going to use our definition here. So we are now going to graph the derivative of that function. So that is equal to negative 5 plus 8x. Graph that. Well, If I look at that, it's negative down below the x-axis, of course, and positive above the y-axis. And if I look at my definition, if the value or the y value is greater than 0 in an interval, then it's increasing. If it's less than 0, then it's decreasing. So looking at this, looking at a derivative function, that means that for all these values, negative infinity to right here, this point right there, the function, our original function, was decreasing, and then from here on out, it's increasing. So what is this magic point here? Well, we just have to solve for x to find it out. I mean, we could also use our calculator once again. You know what? Why don't we use our calculator, then check it to make sure that it's right. So it doesn't have the 0 there. It's a fraction or decimal of some kind. So we'll calculate the 0 value, left bound, right bound. And, you know, this is probably overkill for this kind of question, but here we go. 0.625, which if I want to turn that into a fraction, I could also, if my calculator wants to cooperate, which it doesn't. If my calculator were to cooperate, we would have been able to see. Let's see if this mode cooperates at all. There we go. So 0.625, if we turn that into a fraction, it's 5/8. So let's solve just the other way around now. Hopefully I haven't lost you. If I have, I apologize. So the function f will be increasing when my derivative, negative 5 plus 8x, is greater than 0. Add 5 to both sides. 8x is greater than 5. X is greater than 5/8, which we just found out. And then it's decreasing, obviously, when negative 5 plus 8x is less than 0. So 8x is less than 5, x is less than 5/8. So when x is less than 5/8, it's decreasing. When x is greater than 5/8, it's increasing. And if we look at our original function, once again, we will see that. Here. So if we calculate the minimum value, we will find that minimum hits a minimum with some rounding error at 0.625. So it's decreasing until x equals 0.625 or 5/8, and then increasing from there on out. The way that we would write this in interval notation now, I don't know if we did interval notation at all. I feel like maybe we did it in grade 11 or something. Maybe we didn't. Interval notation, though, lets us know that it is increasing when x is between 5/8 and infinity, but not equal to 5/8. So we use our circular brackets to show that. So this means it is everything up to but not including 5/8, and everything up to and not including infinity. So those numbers, every number that's between these two numbers is increasing. And for decreasing, it's every number from negative infinity to 5/8, not including 5/8. If we haven't gone over this at all, please do let me know, and we will. But if we have gone over it and you've just forgotten, take a look at the rules of intervals, which are found right at the beginning of chapter 4 on page 163. That's example number 1. It was probably a lot more work than we needed to do to get that answer. So let's try and go through the other two answers, or other two examples, a little quicker, just to not get bogged down in the details. So example number 2 has another function. Y is equal to x cubed plus 6x squared plus 9x plus 2. Once again, we want to know, when is it increasing, decreasing? Increasing, decreasing? Question mark. The first step that we are going to do is find the derivative. So the derivative of x cubed is 3x squared. The derivative of 6x squared is 12x. The derivative of 9x is 9. And the derivative of 2 is 0. The next thing we want to do is factor this. Looks like we can take out a common factor of 3. So I will take that out. So I have 3x squared plus 4x plus 3. I need two numbers that multiply to be 3 and add to be 4. Well, that's 1 and 3. So if I solve for that, x plus 1, x plus 3. In the previous example, we had 1 point where things were changing. In this one, we have 2 points where things are changing. So we have two options. We know that the function will be increasing. The function increases when the derivative of y is greater than 0. So we need to solve our inequality here. We can just dump our 3 because the 3 doesn't matter, but I'll keep it here for a second. According to our rules, 3 times x plus 1 times x plus 3 greater than 0 will give us the points on the function where the function is increasing. Now, if we divide both sides by 3, well, 0 divided by 3 is 0. So we're just left with x plus 1 and x plus 3. And we know that if we were to solve this, there are going to be two zeros. When x is equal to -1, the function is going to be equal to 0 because 0 times anything is 0. And when the function is equal to -3, there's going to be a 0 because that's equal to 0. But we don't want to know what happens when it's equal to 0. We want points on the graph where it's greater than 0. So this tells us that there are 3 different intervals on our graph, just solving from our answer. We know that we have from, and let me see, x is equal to 0 when f prime x is equal to 0 when x is equal to -1 and -3. So we have negative, I wrote 8, that should be an infinity. We know from -infinity to the point -3. So -infinity to -3 is one of our intervals, because that's where we're going to hit a 0 point. From -3 to -1 is a second interval. And then from -1 to positive infinity, there is a third interval. Once again, I'd probably just recommend throwing this in a calculator to look at, see what it looks like. So that's what I'll do. I will put in our derivative, keep the 3, don't really need to. But x plus 1 multiplied by x plus 3. And we will see our two zeros at -1, -3. And so we can even tell here. When the derivative is above the x-axis, it's going to be increasing. When the derivative is below, it's going to be decreasing. So our answer, this tells us right here that from -infinity to -3, our function's increasing. From -3 to -1, it's decreasing. And then from -1 to positive infinity, it's increasing again. But perhaps we don't know that. So we are going to make ourselves a nice little table. If we're doing this by hand, we're going to make a nice little table right here. And put our intervals. The interval, we're going to solve for our two equations. Or I guess 3 equations if we include f of x. And then say, are we increasing or decreasing? So our first interval is when x is less than 3. So from -infinity to -3. Our second interval, once again, -3 to -1. And third interval, -1 to positive infinity. When we have any value between -infinity and -3, and we add 1 to it, it's going to be a negative value. So here, in this point in the table, x plus 1, if that x is -3 or less than -3, we know is going to be a negative value. X plus 3, well, the value x is less than -3, also going to be a negative value. Negative times a negative, because we look at this, we have x plus 1 times x plus 3. Negative times a negative is going to be in positive. So, this should be prime. F prime x is positive. Therefore, our function at f is increasing. Between -3 and -1, well, any number between -3 and -1 that we add 1 to is still going to be a negative number. However, if we add 3 to it, it's now going to be a positive number. 2.99 plus 3, or sorry, negative 2.99 plus 3 gives me a positive number. All the way up to, negative 1.01 plus 3, still a positive number. Negative times a positive is a negative. So my function between these 2 points is going to be decreasing. And then finally, from -1 to infinity, anything greater than -1 plus 1 is going to give me a positive answer. Anything greater than -1 plus 3, definitely going to give me a positive answer. A positive times a positive is a positive. So my function, since my derivative is positive, my function is increasing at that time. So that's the test. We have found the test, and once again, we checked it with our graph to make our life a lot easier. Moving on to example number 3 now. Is using our graph. They say to use the graph, though. So we could do that. We could do that. Example 3. We have the function g of x is equal to x to the power of 4 minus 4x cubed minus 8x squared minus 1. Looks pretty scary because it's a 4th level derivative, but they were nice enough to not give us anything to or multiplied by just x. So the derivative, 4x cubed minus 12x squared minus 16x, can be factored quite easily. So we can factor 4x out of everything. And we're just left with, so if we factor 4x cubed divided by 4x gives me x squared, negative 12x squared, I'm left with negative 3x, negative 16x, negative 4. I need two numbers that multiply to give me negative 4, add to give me negative 3. That is negative 4 and positive 1. So if I factor this out completely, x plus 1, x minus 4. So according to our test, the function g of x is increasing when its derivative, 4x times x plus 1 times x minus 4, is greater than 0. I have 3 zeros this time, so I have 3 key points. 0, negative 1, positive 4, which means since I have 3 key points, I'm going to have 4 intervals. You always have one more interval than key point. Unless, of course, you have duplication of your key points. So I have to think about it. Which one is my least value? Negative 1. So my first interval goes from negative infinity to negative 1. My next interval is going to go from negative 1 to 0. My third interval is going to go from 0 to 4. And my fourth interval is going to go from 4 to infinity. Once again, you could just graph this to make your life easier. But why would we make life easy? Why would we make life easy? So we're going to just make it a little more complicated. Feel free to do what you want when you do the questions, though. So we have our interval, and we have our 3 test cases. We have our derivative function, and then we have our original function, increasing or decreasing. Our original interval is from, when x is anything less than negative 1. If x is less than negative 1, well, a negative times a positive gives me a negative. Less than negative 1, negative, negative. A negative times a negative times a negative, which we have here, is going to give me a negative. So it's going to be decreasing. in that interval. Our next interval is -1 is less than 0, which is less than x, which is less than 0. So once again, it's going to be a negative number. So 4 times that negative number is going to be negative. However, this time, our x is going to be between -1 and 0. And so that number, say -0.99 plus 1, is going to give me a positive value. However, that number -4, we're going to be back down to the negative territory. So now we have a negative times a positive times a negative, which gives us a positive. So my interval is increasing. My third interval is between 0 and 4. So 0 is less than x, which is less than 4. Now it's going to be a positive number, so positive times positive number. Positive plus 1 is going to be a positive number. However, this positive number is less than 4, so that positive number minus 4 gives me a negative number. Positive times a negative gives me a negative number. In that interval, it's going to be decreasing. Finally, our last interval, sorry, let me rewrite that. Not 4 is less than infinity. That's true, but not what we're trying to say. We're trying to find any value of x that is greater than 4. So x is less than 4. Pardon me. Wow. Any value of x that is greater than 4. So x is greater than 4. When x is greater than 4, well, these are all going to be positive. Positive, positive, positive. Positives multiplied together give me a positive. So the function is increasing. And once again, you can throw this in your calculator to figure this all out. So just as a recap of everything, there is a test, an interval test that we can do to figure out whether a function is increasing or decreasing. We do this test on the derivative of the function. When the derivative of the function, or the y value, or more correctly, when f prime x is greater than 0, the original function f of x is increasing. When f prime x is less than 0, it's decreasing. I didn't talk about when it's equal to 0, but you probably figured this out already. When f prime x is equal to 0, it is neither increasing nor decreasing. Its slope is 0. So that is section 4.1. If you have any questions, please do let me know. Hope this was helpful. I hope you have a fantastic day, and I will talk to you later.